To determine the domain of G, we utilize the concept of logarithms. That is, logarithm of a positive number is defined and logarithm of a negative number is undefined. So therefore, we say that this expression must be positive. That is, we set up the inequality 2x plus 2 greater than 0 and we subtract 2 from both sides. So we get 2x greater than negative 2. Now dividing both sides by 2 we get x greater than negative 1. And so this is the domain of G. We can put this in interval notation, that is from negative 1 to infinity. And so this is the domain of G. Let's do part B. Here we find g of 127. So we find this by plugging x equal to 127 into the g of x function. So therefore we write g of 127 and this equals log, replace x by 127, 2 times of 127 plus 2. This is to the base 4 minus 3. Now let's simplify this. So this equals logarithm of 2 times of 127 equals 254 plus 2. This is to the base 4 minus 3. And so this equals log 254 plus 2 is 256 base 4 minus 3. Now I write 256 as power of 4. That is, this can be written in exponent form as 4 raised to the power of 4. Because if we multiply 4 with itself 4 times, we get 256. So we can write down this in exponent form as 4 raised to the power of 4. So I write down here, that is log 4 power 4 and to the base 4 minus 3. Now, using the properties of logarithms, we can bring this power in front. That is, this power will get multiplied with this expression. So therefore, this can be written as 4 times of log 4 to the base 4 minus 3. Now we know another property of logarithm, that is log of a number to the same number equals 1. So using this property, we see that this value of the logarithm, that is log of the number 4 to the same number 4 equals 1. So we get 4 times of 1 minus 3 and this equals 4 minus 3 equals 1. So therefore we see that g of 127 equals 1. And therefore we can see that the point on the graph is 127 comma 1. Let's do part C. Here we determine x given that g of x equals negative 1. So I replace g of x equals negative 1 into this function and solve for x. So therefore we get negative 1 and this equals log 2x plus 2 base 4 minus 3. Now I add 3 to both sides. So 3 minus 1 and this equals log 2x plus 2 base 4 minus 3 plus 3. This negative 3 plus 3 cancels and 3 minus 1 is 2. So I write 2 equals log 2x plus 2 base 4. Now we can write the equivalent exponential form of this logarithmic equation. That is, we will have 4 raised to the power of 2 and this equals 2x plus 2. So this is the equivalent exponential form of this logarithmic expression. So this can be written as 4 squared is 16 and this equals 2x plus 2. Subtracting 2 from both sides we get 16 minus 2 is 14 and this equals 2x. Now solving for x from this equation, we get x equals 14 by 2 and this equals 7. So therefore, we found that x equal to 7. And so we write the point on the graph as this is x comma g of x. And so this equals x is 7 and g of x is given as negative 1. So 7 comma negative 1. This is the point on the graph. In part D, we determine the 0 of g. For this, we replace g of x into the function g of x by 0. So let g of x be 0 and this equals log of 2x plus 2 base 4 minus 3. We now solve for x of this equation. So first I add 3 on both sides. So I get 3 equals log 2x plus 2 base 4. Now we write the equivalent exponential form, that is 4 raised to the power of 3 and this equals 2x plus 2 and this is 4 cube. This equals 4 multiplied with itself by 3 times. This is 4 times 4 is 16 and 16 times 4 is 64. So 4 cube is 64 and this equals 2x plus 2. Subtracting 2 from both sides, we get 64 minus 2 and this equals 28. I'm sorry, it is 2x. So 64 minus 2 is 62 and this equals 2x. So we solve for x by dividing both sides by 2, that is 62 divided by 2 and this equals 31. So therefore x equal to 31 is the 0 of g.